Okay, so when we actually inhale air, okay, we know that the whole point of the respiratory system is to get oxygen that's in the air outside of the body into the body so that we can have that gas exchange, so that the air can go from being in the outside world to actually being in our red blood cells, to be carried to all the cells in the body who need oxygen for cellular respiration, right? So, how does this actually occur? This gas exchange, because that's essentially what's happening. Oxygen is in the alveolus and it's got to go from the alveolus to the blood vessel, and carbon dioxide coming from the rest of the cells in the body have to go from the blood vessel to the alveolus. Okay, so in the digestive system, we talked about when substances move from an area of high concentration to an area of low concentration. What is that called? Diffusion. Okay, these gases, so concentrations of carbon dioxide and oxygen will diffuse. It's kind of like they swap places. Okay, and they do this through passive transport. They use concentration gradients to get from point A to point B. So, the actual oxygen-rich air coming into the body, or coming into the alveolus, all right, ends up coming in this way. So this is going to be O2, right? So there's a lot of oxygen inside the actual little sac that is the alveolus. That oxygen has got to go from the alveolus into the actual blood vessel. And those blood vessels are going to be full of little red blood cells, because those are what actually capture the oxygen in the hemoglobin and carry it off to wherever it's got to go. So as these cells come from the actual body, okay, they make their way from the body to the actual lung. They're very high in levels of carbon dioxide. So there's lots of CO2 in each of these. Okay, and as they actually get closer to the alveolus, we see that there's a higher concentration of carbon dioxide in the red blood cells than there is in the alveolus. Where is the carbon dioxide going to want to go? It's going to want to go from these blood cells into, okay, into the actual alveolus. And this happens. So that raises the amount of carbon dioxide in the alveolus. Once these cells get rid of their carbon dioxide, they are free to allow oxygen to come across. And oxygen is in a higher concentration where right now? In the alveolus. There's more oxygen in the alveolus than there is in the red blood cell. Where is the oxygen going to want to go? It's going to want to go from the alveolus to, to the actual blood cells. So that O2 is going to make its way to these guys. So these are little O2s, O2 molecules. And then these guys are going to go back to the heart to be pumped everywhere else in the body. And they're going to bring that oxygen-rich hemoglobin everywhere. Okay, and they're going to drop off their oxygen in cells in the body in exchange for that cell's carbon dioxide. So red blood cells are nothing more than transporters of oxygen. That is their job. Okay, so the high CO2 comes from the body. Okay, from body. And that gets exchanged in the alveolus through diffusion. So all of this is happening because of diffusion. And diffusion, does it cost us energy? No, it does not. And this is happening even when you're not inhaling and exhaling, because there's always an amount of air inside your alveoli. They don't ever get fully empty. So what ends up happening here is the actual carbon dioxide then makes its way out of the lungs through exhalation. Okay? So this is what we call gas exchange in the lung. This is the whole point of having a respiratory system, so that we can get oxygen in the air around us into our actual blood. Other organisms do this very differently. Some organisms actually have blood vessels that are so close to the surface of their skin that gases can diffuse that way as well. Things like bullfrogs, okay, or actually a lot of frogs do this. Okay, we cannot do this. Okay, you were to walk around with no clothes on in the hopes of gas exchange, that's not going to happen. It's like staring at the sun and waiting for photosynthesis to occur. You're not able to do it. So you need to understand what exactly is happening here in terms of the gases, where oxygen is going from, where it's going to, where carbon dioxide is coming from, and where it goes to. And you'll notice here that it's kind of like a swap. Okay? We get rid of our carbon dioxide to be able to take oxygen.